Keuka Energy, based in Florida, has completed and launched the first floating U.S. offshore wind farm, which has been paired with a liquid air energy storage system. The facility is a 125 kW 100 prototype version of a design that the company began to construct in October. The full-scale facility will have a 25 MW rating and is due for completion by January 2017. Each wind turbine blade can drive up to 36 individual components simultaneously and are more powerful per square meter of swept area than conventional turbine blades. They are manufactured from recyclable marine-grade aluminium, each enjoying a service life of around 100 years, and are based on a semi-open center design, thereby reducing downstream turbulence. This also enables more units to be installed per square mile. The blades can easily be lowered to ground level for repairs and maintenance, and can be manufactured using locally available materials. The design helps to reduce costs, requiring much less capital and operations and maintenance (O&M) cost per kilowatt than conventional three-bladed turbine designs. It also eliminates bird and bat deaths because of the multiple blades and slower rotation speed. Offshore wind farms also enjoy much higher wind speeds, 2 to 5%, than onshore turbines, thereby increasing electricity generation while lowering costs. Keuka's design has been paired with liquid air energy storage. This is an abundant and zero-cost fuel supply which involves moving air through liquefaction technology. That liquefying air, by cooling it to minus 196 degrees C, it takes about 700 liters of ambient air to produce around 1 liter of liquid air, and this can then be stored in an unpressurized insulated vessel. When heat is reintroduced to the liquid air, it boils and becomes a gas again. The expansion process can be used to drive a turbine or piston engine. Besides electricity storage, the main other applications of liquid air are the transportation and recovery of waste heat. Liquid air can be used to capture excess energy, including wrong-time energy generated by renewable energy facilities at times when there is low demand. It can be used with grid-scale renewable energy systems, and there is no risk of fuel combustion. Whereas the biggest cost factor in the production of liquid air is electricity, with the liquid air system attached directly to an electricity generator, the required power is fed directly, thereby eliminating costs. The company believes that its floating wind farms are less expensive per kilowatt kW than conventional wind farms, at less than $1 million per MW. The design can incorporate an onboard water or oil-cooled substation which can help to lower costs. Floating wind turbines can also be assembled in areas protected from storms and towed to their locations at a speed of 10 to 15 knots. A 175 MW wind farm can be supported with one common support structure. There is no need for individual yaw mechanisms, as the support structure weather vanes into the wind, and there is no requirement for underwater work either. Another advantage of floating offshore wind farms is that they can be moored in deep water well out of visible range from the shore. Keuka's design also creates calm water areas capable of supporting up to 4 LNG-class tankers simultaneously, so that the liquid air energy storage can be transported to regassing facilities on shore. The company believes its Rain Drive system will revolutionize the industry, while offering inexpensive but reliable wind energy systems that are able to be deployed to remote locations where the deployment of other wind farm technologies is not currently possible. Rain Drive doesn't require a gearbox, because the power is taken from the outer rim, and not the central shaft. This helps to reduce costs, as the gearbox, according to the U.S. Department of Energy, accounts for 25% of the 30-year cost on conventional wind turbines. The liquefaction system for the liquid air energy storage is located at the base of the tower, along with the compressors, generators, and other equipment. This means the weight is kept low, which again reduces costs, because it reduces the stress applied to the turbine tower, and therefore means less need for O&M. Keuka Energy claims that tests conducted by the National Renewable Energy Laboratory, NREL, have shown the ring drive to be more powerful per square meter of blade swept area than conventional turbines. The company owns a 520-acre research and development facility and has spent at least 3 years developing the ring drive technology.